Hello student, today we are going to discuss about the torque acting on a rectangular current carrying coil placed in uniform magnetic field. Torque acting on a rectangular current carrying coil placed in uniform magnetic field. So this is the rectangular coil OPQR. So this is the direction of the current. This is the direction of the current. And OP represents the length of the coil and PQ represents the breadth of the coil. This is the north pole and this is the south pole. This north pole and south pole produces this uniform magnetic field. This is the north pole and this is the south pole, and this north pole and south pole represents this uniform. Have you seen? This is and this is. They are the lines of force of this magnetic field. Now, have you seen this end cap? This end cap is an outward normal drawn on the plane of the rectangular coil OPQR. This end cap is an outward normal drawn on the plane of the rectangular coil OPQR, and this outward normal makes an angle phi with respect to magnetic field. That means when we want to calculate torque acting on a rectangular coil, this angle is very important. The angle made by outward normal with respect to magnetic field. Say this is the coil. So this is the coil. This is a rectangular coil. This is the length of the coil. This is the breadth of the coil. And this is the magnetic field. This black pen represents the magnetic field. This black pen represents the magnetic field. And this paper, this sheet of paper represents the rectangular coil. That means rectangular coil is like this with respect to magnetic field. And this is the outward normal. This case pen is the outward normal on the plane of the rectangular coil. Therefore, this angle is phi angle. This angle is phi angle. Have you seen it? This angle is phi angle. So this plane of paper, this paper piece is the rectangular coil. This black pen is the magnetic field. So the plane of the coil is in this position with respect to magnetic field. And I draw a outward normal, and this case pen is the outward normal, and this angle is phi. This angle is phi. Now, since it has four conductors, OP, PQ, QR and RO. Therefore, magnetic field exerts force on all these four conductors. Magnetic field exerts force on all these four conductors. Okay, now we have to calculate these forces separately. In our representation, we assume that capital N is equal to total number of turns of the coil. Total number of turns of the coil. If N turns are there, so how many wires are here? N wires, N wires, N wires, N wires. Jodi moi ko number of turn 10 boli, tamne enuka conductor mur keidal thakibo, 10 dal thakibo. Okay, so what is the force experienced by a current carrying conductor placed in magnetic field? Etu asil mur F is equal to ILB sin of theta. Aru vector formot likhile F is equal to I L cross B. L cross capital B. Since it has n number of turns, therefore we have to multiply it by n, because number of such conductors are n. So this is in vector form and this is in scalar form or in magnitude form. Now what is this angle? This conductor OP makes an angle 90 degree with respect to this magnetic field. OP conductor is perpendicular to this magnetic field. Therefore angle is 90 degree. So therefore what is the force experience? NIL capital B sin of 90. Sin 90 is equal to 1. So NILB. So therefore force experience on this conductor due to magnetic field is NILB. So what is the direction of the force? Direction of the force can be calculated from calculated from Fleming's left-hand rule. Calculated from Fleming's left-hand rule. What is that rule? Forefinger is the field, central finger is the current, and thumb gives you the direction of the force. So this is the direction of magnetic field. So if we hold like this, so I have to rotate the paper in this direction. So this is the direction of magnetic field. This is the magnetic field. Okay. So this is the central finger. It gives the direction of current. So thumb is perpendicularly inward inside the paper. So therefore, force experience on the direction of the force experience on the conductor is perpendicularly inward. Similarly, what is the force experience on the conductor Q1? It is also 90 degree with respect to magnetic field. So therefore, same force act NILB. L is the length of this conductor. And what is the direction of the force? Again, Fleming's left-hand rule. So this time it is very easy. This time it is very easy. So this is the forefinger field. This is the central finger current, and this is the direction of the thumb. I mean, this force is perpendicularly outward the plane of paper. But this is perpendicularly outward and this is perpendicularly inward. That means if this is the plane of the coil, this force is in this direction, inward, and this force is outward. This force is in this outward direction. This force is along this direction, and this force is along this direction. Now, what is the force experience on PQ and OR or RO? These two angles are 90 degree, but this angle is not 90 degree. This conductor is not perpendicular with respect to magnetic field, because if this is the plane of the coil and this is the magnetic field, then this angle will be a different angles. This angle will be a different angles. It is not phi. The phi is the angle made by outward normal to the plane of the coil with respect to magnetic field. It is a different angle. It may be 5 degree, it may be 10 degree, it may be 15 degree. So what is the force experience on it? Again, Ni B cross B. My factor form likhisu. So what is the direction of the force? This direction of the force is perpendicularly upward. It is upward in the plane of the paper. This force is perpendicular to the plane containing this conductor and magnetic field, and it is upward. So and in this situation, this force is in the plane of paper, but in this direction. মই এবাৰ ভালকে নোটেশনটো শো কৰি দিছো। এইটো মোৰ কন্ডাক্টৰ আছিল, এইটো ম্যাগনেটিক ফিল্ড আছিল। গতিকে ডাইৰেকশন অফ দা ফোর্সটো কোড হ'ব, এইখন প্লেনৰ পারপেন্ডিকুলার হ'ব, এইখন প্লেনৰ পারপেন্ডিকুলার। এইখন প্লেন মানে তোমাৰ কোনটো প্লেন হ'ব? এইখন প্লেনৰ পারপেন্ডিকুলার হ'ব। এইখন প্লেনৰ পারপেন্ডিকুলার হলে তোমাৰ কোন ফালে আহিব? ওপৰ ফালে আহিব, ওপৰ ফালে আহিব। সেইকাৰণে so here to 3-dimensional diagram ase. So therefore this force F2 is in plane of paper in upward direction. Similarly, what is the force experience on the conductor RO? So this force is also in the plane of paper, but it is in downward direction. This angle and this angle exactly same. A2 angle or A2 angle eke gotike yar jiman force experience hobo yato eke experience hobo jeneke yar magnitude of force or yar magnitude of force to eke asil khali direction to beleg yato direction upward or ase etu direction downward or ase. You see one thing, these two forces act along the same line. Since these two forces act along the same line, therefore they cancel each other. But what is the direction of this force? This force F1 and F3, they are also equal in magnitude, opposite in direction, but they act along different line of action. So this force F1 is in downward direction, perpendicularly downward direction, and this force F3 is perpendicularly upward direction. As a result, the coil will rotate due to the action of F1 and F3. The coil will rotate like this. That means F1 and F3 produces a couple. And due to the couple, the coil will rotate in the magnetic field. So what is the moment of the couple? Moment of the couple is the torque. Since the coil rotates, a torque acts on it. And who will produce that torque? The torque is produced by the couple. So moment of the couple, what is the value of moment of the couple? force into perpendicular distance between the two forces. Moment of the couple is equal to either force. Out of the two forces, one force has to be taken. Either force into perpendicular distance between the two forces. Okay? Now this is the case. This force is in this direction and this force is in this direction. We are observing on the top view and this top view is written here. So this is the coil. This coil PQ. This is the coil PQ. This is the magnetic field. This is the force F1 and this is the force F3. Okay? Like this. This is PQ. This is PQ. This force is F1 in this direction. This force F3 in this direction. So what is the perpendicular distance? QM is the perpendicular distance between the two forces. And PM is the parallel distance between the two forces. But parallel distance is not required. We require the perpendicular distance. Therefore, QM represents the perpendicular distance. What is the breadth of the coil? PQ is the breadth of the coil. It is small b. And this is N cap. N cap means it is the outward normal to the plane of the coil. So what is this angle? This angle is phi with respect to magnetic field. So if this angle is phi, this angle will be 90 minus phi. But if we consider this right angle triangle, this is 90 degree. Here this is 90 degree. This is 90 minus phi. So therefore this angle is phi. Now, if this angle is phi, this angle is phi. We have to calculate QM from which triangle? From right angle triangle QPM. So if I consider this angle phi, QM will be base. QM will be perpendicular, PM will be base, and PQ will be the hypotenuse. So if we consider the right angle triangle QPM and we consider this angle phi, if we consider this angle phi, then QM will be perpendicular, PM will be base, and PQ will be the hypotenuse. So what is perpendicular by base? What is perpendicular by base? Perpendicular by base is perpendicular QM. QM perpendicular by base means it is tan phi. Perpendicular by hypotenuse sin phi. So QM by PQ. QM by PQ. QM is the perpendicular, PQ is the hypotenuse. So QM by PQ is equal to sin phi. What is PQ? PQ is the breadth of the coil. Therefore QM is equal to B sin phi. QM will be B sin phi. Therefore torque acting on the rectangular coil is either force F1, and what is perpendicular distance QM. Okay. Now what is the force NILB? What is QM? B sin phi. So L into B, I rearrange the mathematical equation. L into B gives us the area of the coil. Area of the coil. Therefore we get torque is equal to NIA capital B. NIA capital B sin of phi. Sin of phi. A is the area of the coil. Now what is current into area? Current into area gives us the magnetic dipole moment. Therefore NIA gives us the magnetic dipole moment. It is denoted by capital M. So therefore what is the expression of torque? NIA B sin of phi. I again rearrange this equation. NIA is M. So torque is M B sin of phi. So torque is equal to M cross B. So this is the expression of torque acting on a rectangular coil placed in uniform magnetic field. Now we want to consider the special consideration. If phi is 0, what happens? What is phi? Phi is the angle made by outward normal with respect to magnetic field. Say this is the plane of the coil and this is the magnetic field. This is the magnetic field and this is the outward normal. If the plane of the coil is like this, outward normal will be like this. That means outward normal to the plane of, this is the outward normal. Outward normal and plane of and magnetic field is parallel to each other. If I place the plane of the coil in this situation, this black plane is the magnetic field and this is the outward normal, sketch plane is the outward normal, they are parallel to each other. This situation is called phi is equal to 0. If phi is 0, what is sine 0? That means no torque acts on the rectangular coil. That means if the plane of the rectangular coil is in this situation, if plane of the rectangular coil is in this situation, কাৰণ ব্লেক পেনটোৱে মোক মেগনেটিক ফিল্ড বুজাই আছিল, পেপাৰখনে প্লেন অফ দ্য কইলটো বুজাই আছিল। এইটো চিটুৱেশ্যনত থাকিলে কোনো টৰ্ক এক নকৰে। কিয়? বিকজ ইফ আই ড্ৰ দ্য আউটৱাৰ্ড নৰ্মেল, দিজ আউটৱাৰ্ড নৰ্মেল এণ্ড মেগনেটিক ফিল্ড দে বিকামছ পেৰেলেল টু ইচ আদাৰ। Parallel means phi is equal to 0. If phi is equal to 0, sine 0, 0, therefore no torque acts on it. That means if outward normal to the plane of the current carrying rectangular coil is parallel to the magnetic field, no torque acts on it. So my 3-dimensional view to yet a figure of the equation. Next, if phi is equal to 90 degree, if phi is equal to 90 degree, so what is the condition of 90 degree? Okay, this is the magnetic field and this is the plane of the coil. You just see the position of the plane of the coil with respect to magnetic field, and this is the outward normal. Now under this situation, this angle is 90 degree. So this is the plane of the coil, black plane represents the magnetic field, and this is the outward normal to the plane of the coil, then this angle is 90 degree. So under that situation, sine 91, so therefore torque is maximum. That means if the outward normal to the plane of the coil is perpendicular to the magnetic field, maximum torque act on the current carrying rectangular coil. If outward normal to the plane of the rectangular coil is perpendicular to the magnetic field, maximum torque act on it. That means if the plane of the coil is in this situation, no torque act on it, or if plane of the coil is in this situation, the maximum torque act on it. মই আউটৱাৰ্ড নৰ্মেলটো শ্ব' কৰা নাই এতিয়া। প্লেন অফ দ্য কইলটো এনেকৈ থাকিলে কোনো টৰ্ক এক নকৰে আৰু এনেকৈ থাকিলে মেক্সিমাম টৰ্ক এক কৰে। অ'কে, ক্লিয়াৰ? ইট ইজ ভেৰি ভেৰি ইম্পৰ্টেণ্ট ফৰ দিছ ইয়েৰ ফাইনেল এক্সাম।